This exoplanet in the distant solar system appears to have features very similar to our own Earth. It has continents, oceans, and clouds. This star has another planet. This one appears to be a gas giant not unlike Jupiter in our own solar system. As we move further away, the two planets disappear into the glare of their sun. The star now looks like all the other stars in the night sky. How will we ever see these planets? We cannot yet travel there, for the distances to even the closest stars are well beyond humanity's current capability to traverse in our lifetimes. We will have to rely on a space telescope. Housed inside this telescope is a science instrument called a coronagraph that is designed to separate starlight from reflected planet light. As the light makes its way to the coronagraph, we also notice signs of small distortions picked up when the light reflected off the tiniest of imperfections in the telescope's large mirrors. With the coronagraph not yet activated, we see on the monitor what the star looks like through a telescope. No matter how large and perfect the telescope is, it turns what was once a point of light in space into a round disk surrounded by concentric rings, the effect of what is known as diffraction. Somewhere behind the rings of light are the two faint planets. As you're about to see, a coronagraph helps directly image faint planets by doing three things. First, a coronagraph blocks most of the incoming starlight using a mask with a dark central region. The mask is carefully designed to redirect the starlight that it does not block off to the edges of the beam. As we see on the monitor, the inserted mask has already decreased much of the central starlight. Secondly, a coronagraph removes the effects of diffraction. When something that looks like a washer is placed into the light path, it blocks the light in the edges of the beam and the rings disappear. We have now managed to remove almost all of the starlight and are now able to view objects more than 1 million times fainter than the star. But what happens to the light from a planet? Why doesn't it also get blocked by the mask? Because the telescope is pointing directly at the star, the planet's light comes in at an angle, misses the mask, and passes through the center of the washer. But we are still unable to see the planets. If we look closely at the monitor, when we turn up the image signal by collecting more light, what appears to have been a blank field actually consists of blobs of leftover starlight. This scattered light, due to minute imperfections in the telescope's optics, is still hiding the faint planets. So this takes us to the third and last element of the coronagraph, the removal of these scattered blobs. A special mirror is used with hundreds of tiny pistons behind it that can change its shape so as to correct the distortions in the light beam. As the mirror deforms, the blobs of light, as seen on the monitor, slowly begin disappearing, finally revealing the brighter of the two planets. Afterwards, the fainter planet also comes into view. We can now start to see objects more than 1 billion times fainter than the star. Deep within the glare of their star, we have discovered our two planets. And if the light from these is passed through a prism, we will see the light spread out into rainbows of color. But when looking closely, some colors are missing. They were absorbed by gases in each planet's atmosphere, giving us important clues about their composition. The search for life in the universe has taken a new step forward.